Let us now study how to determine the internal resistance of a cell. Okay, it's very simple. So we know that a cell will have some internal resistance. Okay, let's see how to find it. First, you must find the EMF. Okay, to find the EMF, we know just take a cell and connect to a voltmeter. We'll do that and see. Draw it for you. I'll draw the circuit here. Okay, this is a cell here. The cell has internal resistance small r, and then you connect to a voltmeter here. Okay, this we know. Okay, this is a cell will have a EMF psi and the internal resistance is R. Okay, this is a positive and this is negative. This full thing is just cell only. Okay, just a cell. Okay, this is how to find the EMF. So in this step we have found the EMF here, psi. Okay, next what you must do, you must find the voltage of the cell. Okay, or the potential difference. For that what we do is, we'll take the circuit here, the same circuit, only slight modification. The cell is there, the internal resistance is there. Okay, what you do is you connect a resistor there. Okay, connect a resistor R like this way. Connect a resistor, and then you find what is the voltage across resistor like this way using a voltmeter. Okay, so across the resistor you have a voltage here. This voltage will be V, that you can find using the voltmeter. Okay, to prevent confusion, I'll rub this out. Then this is a positive and this is a negative. This internal resistance R and this is the external resistor. Okay, not the internal resistor. Okay, this is cell here. So this is a cell here. Now if you see, it will give us the potential difference between the ends of a cell. Okay, let's now see. We know the formula here from Ohm's law. V is equal to I into R. Let's take this as equation 1. Okay, now we see this voltage. Now this is the voltage we find. Okay, that will be less than the EMF. Okay, why it is less than that? Because of the internal resistance. Okay, so let's see. Now we know that the voltage is less than the EMF. Okay, due to its internal resistance. Its internal resistance. Okay, that is a cause. Now what happens is the voltage V is equal to the internal resistance, or sorry, EMF minus I into R. Okay, we know from V is IR. This is the internal resistance of cell. Okay, so voltage will be less than the EMF by this factor. Okay, now we must know we want to find internal resistance of cell R only. So what I do is I take this minus IR term here. Now this term I will take to left side and V I will bring it to right side. Okay, so what will happen? This will become plus, and V when it goes this side will become as minus. So what happens? We get here IR. Okay, minus term goes this side, becomes plus. That's equal to the EMF psi. Okay, and V goes this side means it become minus. Okay, psi minus V will get. Okay, so this one, this step I'll write as equation 2, and this step I'll write as equation 3. Okay, you divide equation 3 by 1. So divide equation 3 by 1. Okay, when divide this, we'll see what we get. So I into R, small r. Okay, divide this equation 3 by this IR. Okay, by IR is equal to psi minus V divided by. Okay, and this term what we have V here, V. Okay, now cancel the common terms. I and I cancels, so it here small r by capital R is equal to psi minus V by V. We want to find smaller only, the internal resistance. So cross multiply this term this side. So what we have is small r is equal to psi minus V by capital V. Okay, into this capital R. Okay, capital R term. So this will give us the internal resistance of cell. Okay, so here in this equation, what does small r means? It means the internal resistance. Okay, internal resistance. Psi stands for, we know, that is the EMF. Okay, V means the voltage. R means the external resistor. Okay, external resistance. Okay, so if you know, first one, what you do, you find the EMF. Okay, you find the EMF, and then you take a resistor. Resistor value we know. Then you connect the voltmeter and find the voltage here. Okay, so you must know the EMF, the voltage, and the resistance. Using this formula, you can easily find the internal resistance of a cell. Okay, we'll see an example a little later.